Okay guys, this is test 3, the one we just took. How many possible solutions? If you look at just the highest degree, that guy right there should be 3. How many possible turnaround humps? 3 minus 1 is 2. How many positive zeros? You go back up here, look at your sign changes. You have positive to negative is 1, 2, 3. You went from a positive to a negative, negative to a positive, positive to a negative. So that guy should be 3. How many possible positive solutions? Zeros. Right there, we should be looking at Descartes. Plus, minus, complex, total. You know your total is what? 3. For your negative ones, you come up over here and do what? Rewrite it. You have f of minus x. Everywhere you have an odd exponent, it becomes minus. You change his sign, he stays, he changes, he changes. As you can see, you should have no sign changes. This is going right here. You have 0 sign changes, so you have 0 negative possibilities. This becomes 3, 0, 0. Because 3 is already here, you got to have a total of 0. Most people forgot to do what? Subtract 2, that's 1. This is copy, this is 2, this becomes 3. Because 1 plus 2 is 3, therefore you can have either 3 or 1 positive sign, 3 or 1 possible zeros. Possible positive zeros. This is crucial. You're going to see it again on the final. Check your degrees. What's the degree on top? What's the degree on bottom? It's the bottom is bigger than top. So therefore you know the degree on top. My degree on top equals 1. Degree on bottom is 4. It's bigger, so my horizontal asymptote is y equals 0. Right off the bat, find the y-intercept, plug a 0 in there. I end up with 0 over 0. You cannot have a 0 on the bottom, so that does not exist. Go back up here, find a domain. Set the bottom equal to 0. What can you pull out? An x. You're left with an ax cubed minus 27. You set this piece equals 0. You can factor using that the difference of two cubes, or you know that is 8x cubed equals 27 divided by 8 divided by 8. Take the cube root, x equals 3 over 2. Domain cannot be 3 over 2. Find the vertical asymptote, x equals 3 over 2, because the rest of that part is junk. What's the name of the function? F, function of what? X. Once again, look at the bottom. The degree on top is bigger than the bottom. Horizontal asymptote does not exist. Oblique does not exist because it's not one more. Vertical asymptote set equal to 0. If you factor, you're going to get x equals x minus 7, x plus 2. So x equals 7, x equals minus 2. Done. Number 6b, degree on top, same as the bottom, minus 2 over 12 must reduce. So my horizontal is y equals minus 1 over 6. Oblique does not exist. Factor the bottom, you have 12x squared minus x minus 6. That is 72. So that turns out to be 9x plus 8x minus 6. Go practice. 3x, 4x minus 3. What came out of here should have been a 2, 4x minus 3. So my x turned out to be 3 over 4. And my other x turned out to be minus 2 over 3. Vertical asymptote, y equals 0 for horizontal, no oblique. Because the top is not one more. Vertical asymptote, zoom, 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 x minus 8, x minus 3. So x should equal 8, x equals 3. Done. Got to study. This is a function of x. Do not need the parentheses right here. So let me go ahead and erase that. Same thing here. What's your degree on top? Degree on top is 3. Degree on bottom turned out to be 4. Bottom's bigger. Y equals 0. Difference of 2 cubes. X cubed minus 512. That's the bottom. You had to go back and remember the formula. X minus, I think that turned out to be 8. X plus 8. X minus 8. X plus 8. X squared plus, that's wrong, that's going to be x, that's going to be x minus 8, x squared plus 8x plus 64. So that tells me that I have x equals 0 and x equals 8 as my vertical asymptotes, because the rest of it's junk. Right-hand graph polynomial function degree 4 has zeros at minus 3, so that becomes x plus 3. And it has the number 1, multiplicity of 2, so he squared x plus 2. That tells you that 1 plus 2 plus 1 is 4. I know this is right. How do you graph this? Remember, you got to find the y-intercept. We know that y-intercept, plug in a 0, I'm going to get a 6. My zeros are at 1, negative 2, negative 3. I know his multiplicity for 1 is even, so I'm going to go here. I'm going to bounce. At negative 2, he should go through. I got to turn around and come back through at negative 3. So there's your graph. A little messy, but you got the point. Is x to 3 a factor? What do? You plug it in. You go g of 3 equals 4, 3 to the 4th, minus 15, 3 squared, minus 4. 3 squared is 9. 9 times 9 is 36. 36 times 4 is 144. Minus 9 times 15. 9 times 15 is 135. Minus 4 turns out to be 5. If I'm not mistaken, let me check the math. I know 3 to the 4th is 9 times 9 is 81. 81 times 4 3 times 4 is 9. 9 times 9 is 81. 81 times 4 is 324. 324 minus 15 times 9 is 135 minus 4. So that turns out to be, that is not a factor. No. So whatever you get when you plug that in there, let's see what the calculator says. $324 minus 135 minus 4, I get 185. So the remainder is 185 by the remainder theorem. Okay, this one says find the quotient. Anytime you find the quotient, you're just dividing. So we got to go back and do old school division. But before we do that, let's jump down here and catch these guys. This one says list all possibilities, P's and Q's, 21 over 4. You know this is 1, 3, 7, 1, and 2. And what? 4 and what? 21. So your answer is going to be 1 over 1, 1 over 2, 1 over 4, 3 over 1, 3 over 2, 7 over and 3 over 4, 7 over 1, 7 over 2, 7 over 4, 21 over 1, 21 over 2, and 21 over 4. Find the ones that's copies. Of course, these are plus or minus, and then cancel the ones that what? Repeat. Show that x equals 3 is a solution. What are you going to do? Plug in f equals 3 equals 4, 3 cubed minus, right? But instead of doing it that way, let's do some synthetic division. Synthetic division says I'm going to put 3 in, 4 minus 18, 11, 21. That's my remainder column. 4 times 3 is 12. That's minus 6 times 3 is minus 18. Minus 7 minus 21 is 0. Woohoo! That is a solution. Yes, because the remainder is 0. Find the remaining solutions. How do you find the remaining solutions? You come up with the new polynomial, which is 4x squared minus 6x minus 7 equals 0. Got to use the b's. Opposite of b is 6 plus or minus the square root minus 6 squared minus 4 times minus 7 over 2a, which is 6 plus or minus the square root. All that turned out to be 148, because that's 36 plus 112 over 8. That turns out to be 6 plus or minus 4 times 37, which is 2 square root of 37 over 8. Bam, bam, bam. That reduces down to 3 plus or minus the square root of 37 over 4, which are 2. One of these is positive real, one of them is negative, and according to Descartes, that's correct. That's what we should have gotten. Write a polynomial function that has the following zeros. Once again, f of x, that's your polynomial, x plus 2. Then you have x minus 2, x plus 2, x and 2, and both of them multiply. So if we go minus 4, I was thinking this was going to be 4 for both of those. I count it right both ways. Minus 4, minus 5. So his multiplicity is going to be 1. The 2, x minus 2, his multiplicity is going to be 4. X plus 2i, x minus 2i, because he's got a cousin. Every imaginary has a cousin, and both of those multiplicities are 2. So 2 plus 2 plus 4 is 9, because his is 1, his is 4, his is 2, his is 2. So your degree should be 9. Now, let's go back and catch this guy. Long division. Long division, or you could have used synthetic division, but let's see what happens with long division. X plus 2 is x to the 4, x to the 4 plus 0x cubed for representation, x squared plus 0x plus 1. I've got an x, I'm trying to get x4, so that becomes x cubed. That becomes x to the 4th plus 2x cubed. That's a plus. Now you go in and you change the signs. Let's make it red. That becomes minus. That becomes minus. Those cancel. Then this becomes minus 2x cubed minus 3x squared. You're going to put a minus 2x here because you're trying to get a minus 2x squared, or 2x cubed. So that becomes a minus 2x squared minus 2x cubed minus 4x squared. Change the signs again. That becomes a plus. That becomes a plus. Those cancel. This becomes an x squared plus 0x. I'm trying to get x squared. Gives him a plus x. That gives me an x squared plus 2x. Change the signs. That gives me a minus 2x plus 1. So I'm trying to get a minus 2x. So this becomes a minus 2. That becomes a minus 2x minus 4. Change the signs. That becomes a 5. So my final answer is going to be, this is the remainder. So the final answer is going to be all this junk up here, which is going to be x cubed minus 2x squared plus x minus 2 with the remainder of 5 over your divisor plus 2. That's the test. Thank you very much. Okay guys, this is test number 2. You should realize that what you see is, first thing you always got to do, you definitely got to remember your equations. Different quotient is f of x plus h minus f of x. Both of these should be capital F's or lower f's. Second one is even test and odd test. Notice left side is the same. F of minus x equals f of x. F minus x equals f of x. Quadratic equation, b plus or minus square root of b squared minus 4ac, everything over 2a. Discriminant b squared minus 4ac tells you what type of solutions you have. Identify and list all intercepts. There's 2 types of intercepts. Remember that you know that, I'm looking for the pen, you know that x-intercept, y equals 0. So all you have to do is come over here, and where it says y equals 0, you let y equals 0, so that gives you 0 equals x squared minus 9. X squared equals 9. Take the square root, x equals plus or minus 3. Those are your x-intercepts. Then for the y-intercept, you know x equals 0, so 0 equals y squared minus 9. 0 equals y minus 9, so negative y equals minus 9, so y equals 0. So your other intercept is, it's going to be 0, comma 9. That's your y-intercept. These are your x-intercepts. 3, 0, minus 3, 0. It's the following your function. 1, 2, 3, 4. Y is repeat. The x is repeat. So that's a no. Is it 1 to 1? No, because if it's not a function, it's not 1 to 1. This guy right here should be no. This guy right here should be x is repeat. F of x equals the cube root of x. Remember, what's this thing look like? Lazy S. So you know lazy S gonna look like this. So that tells me that yes, y passes vertical line test. 1 to 1 because it passes the horizontal line test. Is this a function? X's do not repeat. The answer should be yes. Why? X's don't repeat. Is it 1 to 1? No. Why is repeat? Next question should be, is this a function? No. Why? Because it fails the vertical line test. And no, because it's 1 to 1. No, because it fails the horizontal line test. Touches it more than once. What is write the equation horizontal line? Anytime you say write the horizontal line, you know it's y equals what? 6, because 6 is the y. X equals what? 5. X equals something is horizontal. What is the thing above called? We call that a rectangular Cartesian plane. See if I can clean that up a little bit. I'm going to go to the typing tool. This is called a rectangular Cartesian plane. You know that the x component, the horizontal axis, is called the abscissa. And you know the vertical axis is called the ordinate. Quick, easy questions, but you gotta know them. Easy points. Next part here says find the difference quotients. Go back to the formula. Everything's all about plugging stuff in. You know the difference quotient. Let's go back to the writing tool. Difference quotient simply says dq is equal to f of x plus h. So everywhere you have an x, you're going to put a what? Minus f of x divided by h. That is simply 3x plus h minus 6. That's that function. Minus, put this in parentheses, brackets, 3x minus 6 over h. That cleans up to be, if you do all the work, it turns out to be 3h over h. H is canceled, so that turned out to be 3. This guy right here says find f minus g. So you put f minus, and here's the mistake most people makes. They forget to put this in parentheses. So when you dance this, that's 3x plus 4 minus 2x squared plus 8. So now that becomes in order minus x squared. Let's undo that a little bit. That becomes minus 2x squared plus 3x. A plus 8 plus 4 becomes 12. Watch the signs. Next one says f plus g 3. So all you have to do is what? Put a 3 for f. 3 times 3 plus 4 plus 2 times 3 squared minus 8, which is 9 plus 4, right? That becomes a plus 6. Nope, that's squared. That becomes plus 3 squared is 9. 9 times 2 is 18 minus 8. So I know 9 plus 4 is 13 plus 10. That becomes 23. This guy right here says division. Plug in the 2. I get 3 times 2 plus 4 over 2 times 2 squared minus 8, which is 10 over 0, which is equal to does not exist. A lot of folks made that mistake. 0 on the bottom is always what? Does not exist. Coming to the bottom, this is a composite that says put 2 inside of g first. We remember that g was 2x squared, so that becomes 2 squared minus 8 equals 0. Now you put that 0 inside of f, and you get 3 times 0 plus 4. Let me check that function. So the answer should be 4. This guy here says put 2 inside of G, which we did once here. So that gives me a 0. So now I'll put 0 inside of G, and that gives me 2 of 0 squared minus 8, which is negative 8. It says find your domain. Domain says set junk on the bottom. That gives me x squared equals 9. Take the square root, take the square root. X equals 3, x equals minus 3. So my domain is x equals 3, x equals minus 3, not. And what? Not. There it is. Once again, crucial. Find y-intercept. Simple. X equals 0. The answer should be minus 7. Y-intercept point, 0 minus 7. X-intercept, 0 equals 3x squared plus 4x minus 7. You have to either use the beast or the bridge over troubled water to see if you can factor this. It turns out to be plus 7x minus 3x minus 7, because this is 21. Don't forget your tree. Factor out an x, I get x plus 7. I factor out a negative sign, I get 3x plus 7. So this turns out to be x minus 1 and 3x plus 7 equals 0. Set both pieces equal to 0, which gives me x equals 1 and x equals minus 7 over 3, which says x equals minus 1, kill it, and x equals minus, don't kill it because we're looking for the x-intercepts, minus 1. And we know we have x equals minus 7 over 3. So my x-intercept is minus 1, 0, and minus 7, 3, 0 is your x and y intercept point, your x-intercept points. Next part says, is negative 4, 3 on your part of the answer? Well, this is an x, this is a y. So you go find f of 4 equals minus 15 plus 3 times 4 over 7 minus 2 times 4, which is minus 15 plus 12 over minus 1, which turns out to be minus 3, which does not equal to, whoa, minus 15 plus 3 times 4 is 12. 7 minus 2 times 4 is 8 minus 1. Minus 4 is minus 3 over minus 1, which turns out to be 3, which is not negative 3. So the answer here is no. Find the domain of the axis, no junk on the bottom, all real numbers. Right? Notice graphic notation, interval notation. Everything shaded. Interval notation, minus infinity to infinity. Set the junk equal to 0 on the bottom, minus 7, minus 2, plus 2. Set them equal to 0. So that says x cannot be negative 2. Pick back up again. It's going to be negative infinity, negative 2, or negative 2 to 7, or 7 to infinity. Open circle, since it's come from the bottom, should be negative 2, 7, Shade, 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 shade. Set each piece equal to 0. Number 12, got a square root. You know you got some shading somewhere. So you got to be able to set it equal to 0. I get minus 2x equals minus 7. So I get x equals 7 over 2. So x equals 3.5. Put my circle, 3.5. Test my region. This is 3.5. 3.5. I'm going to let x equal 0. When I stick a 0 in there, I get the square root of 7. That's good. Check this side just to be case. Pick x equals 4. I get a negative sign. That has to be bad. Close circle because it's on top. Here comes the shading. Here comes the interval notation. Negative infinity to 3.5. Bracket because it's on top. This is a closed circle. Question here says interval of decreasing. That's decreasing. That's decreasing. That's decreasing. So we should be going from where? Minus infinity, open, minus 3 because it's the x, or minus 1 to 1, or 3 to infinity. Notice that's the interval of decreasing, but how do you report your answer? You look at this part right here. Where does it stop? There it is. Where does it stop? There it is. Where does it stop? There it is. That's your decreasing. Now, look at the interval of increasing. Increasing goes from where? Here to here, because this is where it's increasing. Increasing goes from where? Here to here, because that's where it's increasing. So my answer should be from negative 3 to negative 1, or 1, 2, 3. And does not exist because no, when it says a constant, it should be where the graph is flat. The question says find the absolute minimum. Well, this is the lowest point, which is minus 9 minus 6. So the value is always the y part, minus 6. Find the absolute maximum. Same thing here. What's the highest it is? It is 8. Next question. Find the relative maximum values. Relative maximum values is everything is a maximum. So all my values should be minus 2. Sorry. My maximum is going to be minus 2, 4, 8, and 1. Minus 2, 4, 8, and 1. My minimum value is going to be who's the lowest. Relative is going to be what? Minus 6. It's the values. Minus 6, minus 2, and minus 2, which you already got. So I have minus 6 and negative 2. Negative 6, negative 2. Where's the absolute maximum located? You know that's got to be x equals. So the absolute minimum is located at x equals, right here, x equals negative 9. F of f says when my x is 4, what is your y? When my x is 6, what is my y? So I'm going to go to 4. Boom. I get a minus 2 for my answer right there, because that point is 4 minus 2. Minus 2. Same thing for that guy. You have a 0.61. That's why that's 1. F of x, that simply says y equals 0. So where do you have y equals 0? You have y equals 0 at several places. Here, 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 and here. So rough estimate, I'm going to say -5, -2, -5, -2, 3, -5, -2, 0, 3, and 5. -5, -2, 0, 3, and 5. Let me check to see if those are my x-intercepts. Yep, pretty close. Now you go back down here. This one says, what is the left-hand end behavior and right-hand end behavior? What's it trying to go to? Left-hand side is trying to go to what? -2. Right-hand side is trying to go to what? 1. So this guy here should be -2. This guy here should be 1. This stuff here, just plug and chug. It says what? F of 4. Everywhere I have an x, what I'm going to plug in? A 4. So that becomes what? 4 squared minus 2 times 4 plus 16. That should be 16 minus 4 squared is 16. 2 times 4 is 8 plus 16. 32 minus 8 should be 24. This says f of 0. Plug a 0 in. So that means everything goes away. So the thing you got left is what? 16. Next one says, find x when f of x is -20. Let that be y minus 20. So f of x, this says f of x equals x squared minus 2x plus 16. What is f of x? Minus 20. So put minus 20 in place of f of x. Bring that 20 across the bridge. You end up with x squared minus 2x plus 36. You got to use the beast on that one. A equals 1. B equals minus 2. C equals 36. The formula says the opposite of b plus or minus b squared minus 4 times a times c, which is over 2 times a, which is 2. That becomes 2 plus or minus square root of 144. That is 4. 4 times 36 is 144. 4 minus 144 equals minus 140 over 2. So I think that turned out to be 2 plus or minus the square root. There's an I. You know, that guy right there is 4 times 35 over 2, which is 2 plus or minus 2 square root 35i over 2. So that turns out to be 1 plus or minus I square root 35. Done. That's your solution. This one says find the inverse. How do you find inverse? Everywhere you have an x, you put a y. Remember, this was the original problem. It's supposed to have x's here. My mistake. So first step is y equals 2x plus 6 over 4 minus 2/3 x. X's become y's, y's become x's. 2y plus 6 over 4 minus 2/3. We did this one in class. You got a fraction. 4 minus 2/3 x over 4 minus 2/3. Yeah, give him some 4 minus 2/3 x. When you multiply this right here, you should have a 4x minus 2/3 x. Y equals 2y plus 6. When you give everybody a 3, that should become 12x minus 2xy equals 2y plus 18. Divide everything by 2, I get 6x minus xy equals y plus 9, right? That means now everybody with a y is going to go over there. So that gives me minus y minus xy minus xy minus y equals minus 6 plus 9. Change everybody's sign. Xy plus y equals 6x minus 9. Pull out a y. That gives me x plus 1 equals 6x minus 9 divided by x plus 1 divided by x plus 1. Cancel. That gives me y equals 6x minus 9 over x plus 1, which tells me the inverse is 6x minus 9 over x minus 1, x plus 1. So now I know my domain of this guy is x negative 1, which is the domain of the inverse. So that becomes the range of the function. The domain of the function, x cannot be 6, is the range of the inverse of the function. I got to clean that up. Okay, here comes the review stuff. We've talked about this. You've got several examples. Transformations, horizontal shift, 3 right, vertical shift, 1 up, and reflection across the x because of the negative sign. Horizontal shift, 2 right, vertical shift, 1 up, compression, stretch, because 4 is greater than 1. Horizontal shift, opposite of negative 5, 5 right, vertical shift, 2 up, reflection across the x. Now, you gotta go back. What's the domain? Draw the picture. Well, you know the domain is gonna, since it's a cube, x cubed plus 1 minus 1 shift. So I know it's gonna be 1, 2, 3 plus 1 right here. You know it's gonna look something like this. So my domain has to be what? All real numbers. Don't forget to find that y-intercept. Plug in a 0. That gives me 27 halves, 13 and a half. Because 0 is 27, half a third 27 is 13 and a half. So that y-intercept is 14 and a half. Y-intercept for this guy does not exist, which makes sense because we shifted this guy 2 over 1 up, 2 over 1 up, and that's what he looks like. His domain is 2 to infinity. His range is 1 to infinity. This guy here is all real numbers. This guy here is all real numbers. This guy here was an absolute value, 5 and 2. So he went over 1, 2, 3, 4, up 2, came down like this, because his y-intercept should have been 0, 3, about negative 1. And I just quickly threw it on there, and I got lucky. I hit it. So that's minus 1. That tells you his domain is negative infinity to infinity. That tells you his range is negative infinity to 2.